People are slowly joining. We had actually 300 people registered for this webinar. So great to hear the good interest. And usually 1/3 or so show up. So let's see how many show up for today's webinar. Well, hello again. Thank you for joining our online training workshop on electrification of heating in textile industry in India. My name is Ali Hasanbeigi. I'm the founder, CEO, and research director at Global Efficiency Intelligence. We are a consulting firm based in the US, focused on industrial decarbonization across different industries and different regions and countries. And textile industry is one of the sectors we have done fair amount of work on. And myself actually have textile engineering background, and I've done work on textile industry in the past 20 plus years. And in recent years, we have been doing also good amount of work on electrification of heating and deep decarbonization of textile industry. And I have with me my colleague Puneet from WRI also, who will be presenting during this workshop. Puneet, would you like to introduce yourself?
Thanks, Ali. Good afternoon, everyone. I am Puneet Khandelwal. I am Head of Utilities and Finance in WRI India. WRI is an international think tank. So specifically in energy program at WRI India, we are working on the emerging as well as the burning issues related to the energy transition of the all the segments of the energy consumers, specifically electricity. And with respect to the textile sector, we are working in the clusters of Tirupur as well as analyzing other clusters in terms of what are the issues, what are the industrial heat potential, as well as what are the corporate RE pathways which the companies are adopting and may be adopting in the future. Yes, thanks, Ali.
Yeah, thank you, Puneet. You'll be hearing much more from Puneet a bit later on. Our biggest challenge is time. We have a lot of good material we have prepared, but limited time. So let's get started. But before that, a few housekeeping items. We do have a Q&A session at the end of our workshop. So anytime any question pops up, so please put it in the Q&A box here. We are recording this workshop and we'll be sharing the recording later online. You won't be able to participate in the discussion kind of verbally, but certainly we are hoping you participate by putting your question in the question box. And also we have a few polls during our presentation, so please do participate during those polls as well. And some of the materials that we mentioned, we will also share some links to you either during the workshop or later. So with that, let's get started. One other thing, I mentioned global efficiency intelligence, but I also would like to introduce two platforms that we have, which is very relevant to this audience. One is Textile Sustainability Hub. We launched this over 7 years ago, where we share our work on textile industry decarbonization, as well as our other colleagues, some of the major other publications and tools that are out there, we share in that platform. And also Industrial Electrification Center we launched over 2 years ago, where we share all the work we are doing on electrification of heating across different industries and technologies and countries we share there. So if you're interested in this topic, I encourage you to check those platforms. Everything is available for free. So today we have two major component to this online workshop. The first part is on electrification of heating in textile facilities in India, and I'll be presenting that part. And then the second component is corporate RE procurement in India, with a focus on textile companies. And Puneet, who is an expert in this, and I've been working with WRI India on this, will be presenting. And at the end, we will have the Q&A session. But do put your questions in the box throughout the workshop. So before I get started, we have done a number of webinars with similar title. And we have published a number of studies on textile industry electrification and many more on other industries electrification in the past few years. But the previous studies and webinars were more focusing on why we want to electrify and what is electrification and what is the impact of electrification. Techno-economic analysis, introduction of the technologies and pros and cons and all that, which are all useful. And you can find those in our publications that are available online and the webinars that we have. So for this, as the title say, we actually call it a training workshop. We wanted to focus on how, go beyond why and what to how. And that's what Puneet and I will be focusing for most of our presentation. We will have a few slides on why and what, and then we will focus on how. But even that how is very difficult to, just present in 20 minutes or so. And actually, as we speak, I'm developing a 5 hours workshop on textile industry electrification, which is a different project, different initiatives you might hear more about later. We are going to basically walk you through different steps when it gets to how you start from basically zero to electrified technology working in your plants and what are the steps that you need to go through. It's not just a one engineering task. So that is the intention of this workshop. Hopefully we will be able to do that. But having that said, let's very briefly talk about why electrification and what is electrification. So in case of India, India textile industry actually is quite large, one of the largest in the world, and it uses a lot of fossil fuel, and electricity that it uses also is very fossil fuel dependent, carbon intensive grid. The recent estimates basically shows that India's textile industry emits around 49 million ton of CO2 per year. That is scope 1 and 2 emissions from textile industry in India. That's a large number. That's larger annual CO2 emission than 150 countries' annual CO2 emissions. So it's a big number we are speaking. Therefore, a big challenge, also the big opportunity to decarbonize. Significant portion of fuel used in Indian textile industry is fossil fuel. Some biomass is also used. And fair amount of dependence on coal, which is a very carbon intensive. So that's what we want to decarbonize. And electrification allows us to basically phase out fossil fuel and then tie electrification to renewable in order to decarbonize. In a textile plant, I think majority of people on this session, they are working in textile companies one way or another. So you use electricity and you use fuel. And significant portion of fuel actually is used for heating in especially wet processing facilities where we have pretreatment, dyeing, printing, finishing, etc. Electricity component to decarbonize that is becoming more and more straightforward in many geographies and fortunately in India. The past 5 years especially, a lot has changed in a good way and it's just moving in the right direction with regards to corporate RE procurement that Puneet is going to talk about. So India actually is one of the best geographies in Asia when it comes to corporations procuring renewable. So that's a good news and it's more straightforward. We are not saying it's easy, still you have to go through this step, but that's more straightforward. It's the heating that is challenged, how to decarbonize heat, but decarbonize meaning deep decarbonization towards net zero. And that's where people are scratching their head. And that's where electrification offers a real long-term, real decarbonization solution. And those are technologies like industrial steam generating heat pump, electric boilers, and other technologies we have discussed before. But the two main technologies are industrial heat pump and electric boilers that can replace the conventional fossil fuel boilers and then tie that electrified heating to renewable. There you go. You can get to net zero if you do it today, even today. So we did publish a few months ago a major report about, I think, 100 pages on electrification of heating in textile industry in India, where we did the analysis at like 4 different levels, at the national level, country level, at the state level for 3 major states, Gujarat, Tamil Nadu, Maharashtra. At the cluster level, we did analysis for Surat cluster and for a typical wet processing plant in India. We published a detailed techno-economics of it, how much the saving, how much CO2 reduction, what would be the cost. So there you go for all the what and techno-economics data of everything we are discussing today. I'm not going to talk much about that today. But that by far is the most comprehensive report published on this topic for India, I would say. But very briefly, for those of you who may not be familiar, the technologies we are talking, the two major electrification technologies, heat pump, industrial heat pump, and electric boilers. And when I talk about heat pump today, I mostly talk about a steam generating heat pump because we do need a steam for many processes in textile industry. Even they have lower temperature requirement, the steam is needed to deliver the heat. Heat pumps they have been around for decades actually. There's nothing new about them. And a steam generating heat pump for high temperature, they are just emerging more and more. But they have been commercial, they have been around. The reason they have not been adopted because the preconditions were not there, because the economics, renewable, the policies, etc. But now those preconditions are lining up. Heat pump is basically like an AC in reverse, like air conditioning. So it gets the heat from lower temperature. It's preferred to have some base heat and then uses electricity as an input to lift the heat and then delivers it at the higher temperature. It moves heat. It doesn't generate heat the way the boiler does. As a result of this moving heat, it can have extremely high efficiency, which is measured in terms of coefficients of performance, coefficient of performance, COP. Heat pumps can have COP of like even 6, 7, or 5, but those are for lower temperature and smaller temperature lift. For a steam generating heat pump that we are talking today, COP is usually between 2 to 3. And that is, in simple terms, is 200% to 300% efficiency for a steam generation. Compare that to the 70% or 8 to 80% of conventional boiler. So you can see heat pump is extremely efficient. And it can deliver steam up to around 170 degrees C, and some claim even higher. Very briefly on some of the results of the study we did for India. This is for a typical textile wet processing plant. If you install a steam generating heat pump compared to a kind of conventional coal boiler, what would be this annual energy use and annual CO2 emissions? The graph on the left-hand side shows the annual energy demand for the typical wet processing plant in India with 8,000 per ton production. You can see conventional boiler requires significantly larger energy compared to the heat pump because of the efficiency gain that I just told you. And translating that into CO2, you can see the significant drop in annual CO2 emission. The first bar is the conventional steam boiler, coal boiler, annual CO2 emission. And the subsequent bars, the green one is for the heat pump in 2030, 2035, and 2040. The emissions associated with heat pump operation, of course, depends on where the electricity comes from. So we have two scenarios here. The first bar for heat pump shows basically a scenario where we assume 50% of electricity come from grid and 50% through corporate RE procurement, which Puneet is going to talk about. Which is possible even today, by the way, in India. We are not just hoping for something in the future. And then as the grid decarbonizes or as you include more renewable percentages in the electricity supply, you can get to significantly low emission or even zero emission. So this is kind of a snapshot of some of the results of our analysis. Much more you can find in the report. Electric boiler is another technology, completely different. It's fairly similar to conventional boiler. Instead of using combustion fuel, basically use electricity. It's like your stove can be natural gas or can be electric stove. It's basically the same concept, electric heating. And I don't get into the detail of the technology. There are different types for small or larger boilers. But electric boilers, basically industrial electric boiler can give you efficiency of 99% compared to conventional boiler of like 70 to 80%. So they're very efficient, but they are not as efficient as heat pump. Therefore, the technology of choice usually for electrification is industrial heat pump. But industrial heat pump, they have high capital costs, high capex, whereas much significantly lower energy and operational costs because of efficiency gain. Electric boilers, on the other hand, they have fairly low capex. They're cheaper than even coal boiler or biomass boiler, but they increase your energy costs because electricity is more expensive. So there are pros and cons, and then certain decisions that need to be made based on that. We have all that analysis and results in our report again that I showed you. But one snapshot of the cost analysis, we put all the costs, the capital costs, operation costs, energy costs into a framework of what we call levelized cost of heating. And you annualize all the costs over the lifetime of the technology, and then net present value of that divided by heating that provides, you get a dollar per megawatt hour of thermal energy that is provided. And here, the first bar is coal boiler. The second and third bar, they are electric boilers, different scenario. And the last two bars are heat pumps, steam generating heat pumps. You can see that steam generating heat pump by far have the lowest levelized cost of heating. And even if you remove the small CO2 carbon price that I've included here in this analysis, still steam generating heat pumps are cheaper over the lifetime of technology, save you a lot of money compared to coal boiler. These are based on actual cost data in India, so we have not made this up. This is also despite the fact that heat pumps, they have significantly high capital cost. This dark blue is capital cost. You can see heat pump, the dark blue is much larger than the other technology. But because over the lifetime, they save you so much energy cost, the levelized cost is significantly lower. So that's something to keep in mind. So that was very quick run through, a very quick summary of a 100 pages report into a few slides on why to electrify and what is electrification in a very high overview, and also what is the impact CO2 energy cost. Now let's focus on the main reason we are having this workshop on how we can electrify. And to do that, we go through certain steps on how we can integrate electrification technology into a textile plant in India. So before doing that, we do have a poll. Let me try to, my colleague usually help me with this, but she's in US, and that's why I have to do it myself. So let me launch a poll here. Please do participate and answer this question. There are just 4 answers you can pick. What is your biggest concern about electrifying heating in your facility? The answers are electricity cost and tariffs, grid capacity and reliability, production quality risk, and capex and payback. Please do answer, and I will share the answer with you. I'll give it like 30 seconds for people to answer. Thank you. Looks like we have over 100 people here, so yeah, 113 people. Eighty people have responded so far. Okay, let's see. Interesting results. Can you see the poll result?
Yes,
Puneet?
it's visible. Yes.
So it looks like majority of respondent electricity cost and tariffs and capex and payback is the main concern. Grid capacity and reliability concern, but not as significant, and production quality risk not. So very interesting. But thank you so much for participating in the poll, and let's continue. Okay. So here are the steps different people might put it in different categories or steps, but here are 9 steps from 0 to 8 on electrification. It's not, one engineering. If you're an engineer in a textile company attending this, you might be used to like doing an engineering task. This is a process, and there's a decision-making process, different components. And we will fairly quickly need to, I see I have like 15 to 20 minutes left, need to basically walk you through these steps and what might be involved. So step 0, before you even start, you need to define your objective. Why are you even electrifying? Why are you looking at this? Is it the pressure from the brands? Is it, you have a SPTI target? And the answers to these questions actually will have implications later on how you do this project, what technology you choose, what financing you might have, and so on. Also, the timeline. Is it just a small pilot project, or is it part of a larger transition plan that you have for your current plant, or if you're a bigger company, for a number of plants? Some of your initial requirement, we know like typically the people, for example, have a 2-year, 3-year payback period. Are there other requirements with regards to standards, production, finances, etc.? And as I said, you have to define those, and later on you will see these answers and anything else you might think of as an objective uh, in the beginning that you need to define in order to basically have a more clarity in order to proceed. So once you define your objective and actually, you want to go ahead with this, the first thing is you need to have proper inventory of the system. The step 1 is inventory of the system, and there are different inventories. So first is the heat supply assets. You would be surprised. We have been doing projects with different countries, different companies, different suppliers, that how many textile plants do not have some of the most basic data when it comes to especially heating. So you have to have that. I mean, you cannot go electrify your plants without having the proper data. So just the nameplate is not going to cut it. So you need to have detailed information about your boilers. You need to have good information about your load. What is your base load? What the backup load is, and the variability of the load, etc. You need to know where your fuel is coming, the price volatility, and all that. It all comes into the picture when later on we do the analysis. And this will help you to define, based on your load and equipment, what you can electrify now or in the short term, and what you basically keep in terms of fossil fuel, and later on you can go and electrify. So again, part of step 1 is mapping your steam demand. As you all know, steam is used in different processes, different machines, not in the same way, not in the same kind of pressure, temperature, time. So you need to map your steam demand and have your actual demand that is needed in different processes. And as you know, actual demand is definitely much lower than the installed capacity. And that comes into picture later on, as you will see. So you need to know what's your minimum demand, what's your average, what's your peak, and this will help you significantly to size your system properly, which has significant implication with regards to operation of your system and also cost. Part of step 1, again, inventory of the system, you need to establish a baseline for your plant with regards to fuel use, energy use, emissions, and cost. And fortunately, as part of your reporting, perhaps to different brands or other requirements that you might already have this, like how much fuel you are using, what's the efficiency of your equipment, what's the emissions associated with the energy use, and what's the cost in terms of energy cost per kilogram of fabric, steam cost per kilogram of fabric. And one thing we would recommend also, levelized cost of heating. Actually, we have a tool that can calculate that for you. Later I will show you. So the more detail, the better if you have this information. This is all part of step 1. So step 1 is to establish the baseline, the data, and have the better data you have, the better decisions you can make. Step 2 is selecting the strategy for electrification. So electrification in one line is not an all or nothing decision. Like a lot of you might look into it and you say, okay, this is not for us because, for example, our peak cannot be met with industrial boiler, electric boiler, or heat pump, and so on. This can be a hybrid strategy, which actually is what we are recommending, and a phased approach. So what is this hybrid strategy that we are proposing? Meaning that you have a design that you electrify part of your load, let's say 70% of your load, could be 50% of your load, and should be base load most likely, especially if you are using heat pump. And then for your variable load or peak, you can still continue have your fossil fuel or biomass boiler as the peak or backup. And then later stages, you can electrify those as well. So this actually has an advantage because you are going to have some need for infrastructure, electrical infrastructure to connect your electrified heating. And the lower load that you have, the easier it gets to connect your electric load, the new electric load, the heating to the grid and so on, reduce the cost. But at the same time, even if you electrify 50% or 70% of your load, you're significantly reducing your emissions. And I'm sure you will meet many of your near-term targets. So keep in mind hybrid strategy. Technology selection. We have discussed it extensively in our reports, the one I showed you for India, but also we published two major reports in the past 1 year. One was called Low Carbon Thermal Energy Technologies for Textile Industry, another one called Low Carbon Thermal Energy Roadmap for the Textile Industry. Each of them 100 pages report. It was supported by Apparel Impact Institute. I highly encourage you to look at those reports where we show the pros and cons of each of these major technologies. But for steam, basically, your choices are steam heat pumps or electric boilers. Steam heat pumps is the technology that first we would recommend because, I mean, it's a no-brainer. You have a technology that has 200, 300% efficiency. Why would you go with a technology that has 99% efficiency? But it does have high capex. So if you cannot, there's no way you can get that higher capex, then you can go with electric boiler. And even though nominally it might have higher energy OPEX costs, but there are conditions that depending on your tariff, renewable procurement rate, etc., you could in even near term get lower energy costs compared to boiler, including some carbon costs, etc. So it's not that electric boilers are bad. It's just you need to look at all the pros and cons and your own conditions. And again, to further help you with that, we developed this decision tree for textile facilities that want to adopt electrification technologies or even looking into biomass. And again, I don't have time to run you through this decision tree, but basically, depending on your corporate RE procurement options, which fortunately in India is in moving in the right direction, is in a good position, and your energy costs, your electricity to fuel price ratio, etc., it will guide you whether you install a steam heat pump or electric boiler. And if certain criteria is met, also it guide you through it's okay to have sustainable biomass boiler in the near term, but then later on you can reconsider. So check out that decision tree from our previous publication. But then the next step is assessing your infrastructure, because you get significant additional electric load that you need to connect. So you need to be prepared for that. So estimate your load first. If you electrify, how much will be your additional load? And it's significant. And keep in mind, one additional benefit of heat pump is because of that significant efficiency, 200 to 300% efficiency. That means significantly lower load it needs compared to electric boiler. And that saves you a lot of headache and cost also when it comes to your load connection. But you need to look at your constraints too. Like, for example, you might say we have, 1000 kVA connection, but if we electrify, we are going to need 2000 kVA. What do we do? So the first thing you can do is talk to your electric utility and they upgrade your substation. Or you can go to the phase approach and instead of electrifying 100%, you electrify depending on all these conditions, for example, 50% or 70%. That means reduced load demand as well. So there are things you can do, but the first thing is you need to know what would be your load. And the tool that I'm going to introduce actually will give you that answer. But in the study that we did for India, for a typical wet processing facility with 8,000 ton per year production, we have the numbers around a bit higher than 8 megawatt additional load if you use electric boiler. But significantly lower, you need a little more than 3 megawatt only if you use a steam generating heat pump. Again, because significantly more efficient steam generating heat pumps are. And if you electrify your thermal oil boiler, which we are not talking much today about, you need thermal oil boiler to have the hot oil to go through your stanter for heat setting. You can electrify that too. For such a plan, you would need around 7 megawatt additional electricity. So these are the numbers. If you have significantly lower production, then you can scale from there. So once you have a good understanding of your load, then the step 4 is evaluate the feasibility. There are a number of feasibility, technical, economical. Let's talk about technical. So you need to figure out, technically speaking, your plan, how this new system, heat pump or boiler, gets connected to your existing facility. Space, of course, they're going to need a space. Where do you put all this? They're going to need maintenance. Where do you get the maintenance service? I mean, you do some in-house, but you need additional to that. The best is to engage with vendors from day one. They would literally come to your site and visit, and they will tell you all the things you need and all the constraints you have, so you will make an informed decision. Continue on step 4 on evaluating feasibility, production risk and quality. Looks like you were not that concerned about it from the poll. But these are slightly different technologies, heat pump, and actually they are more advantageous. For example, heat pump and electric boiler, they have faster ramp up rate compared to coal boiler biomass. That's an advantage. But you need to be aware of this because temperature stability is important, for example, for dyeing and etc. So the way to do that, from day one, you involve your production and quality team, and they will tell you exactly the spec they need, and you make sure you design the system based on the demand of your production. And also, to mitigate any risk, you can do electrification in the phased approach, as I mentioned earlier. So that's an additional benefit here. Typically, you want to run a steam heat pump. They're very efficient if you have them run as a base load and then have the boiler for the peak load or variable load. Part of step 4 evaluating feasibility is, I talk about technical, but economical feasibility, CO2 and cost, but also CO2 perhaps. So we do have textile heating electrification tool, which we developed and published about a year ago. It's available for free in 6 languages. You can download and use it today. And it does a fairly sophisticated, actually, pre-feasibility study that if you hire a consultant, they would charge you tens of thousands of dollars. So the tool actually has 2 modes. One is the simplified analysis, one is detailed analysis. In the simplified analysis, you can put just a few numbers about your production and annual energy use, and the tool has default values, and it will do the rest of the calculation by itself and give you the result. Of course, if you run the detailed mode and put your numbers, the results are more customized to your situation. So we encourage you to run the detailed mode. But then it does the techno-economic analysis, will give you information on heat pump, electric boilers, your current conventional boilers, coal, biomass, whatever you put in there. Also thermal oil boilers, if you electrify them. And it compares the annual energy use, annual CO2 emissions for 2030, 35, 40 runs into future. You can run scenarios with regards to renewable RE procurement percentages, and it can really do a fairly good detailed calculation depending on what numbers you put there. It does have built-in vendor database for electric boilers and industrial heat pumps in 20 different countries, 10 to 20 different countries maybe, including India. And it does have a simplified action plan based on the result of your analysis. So once you get your result, based on that result, you get some action plan. So it's a fairly detailed tool, I would say, while it's user-friendly and Excel-based. So I highly encourage you to run that for your electrification effort. And to move on with step 4 and step 4, the last is, you need to include non-energy, non-monetary benefit. Often electric technologies have better control compared to combustion technology, and better control, temperature controls and others, they improve your production quality and reduce waste and save you money. As I said, electric technologies, they have faster ramp up, so that helps you with production flexibility. Often the O&M is lower for electric technology, and they are cleaner. I mean, you have literally no local pollution, no air pollution, safer environment for staff to work. And heat pumps actually, they generate cooling as a byproduct, which you can, use for cooling the factory floors, the office workers, and all that. So improve working environment. These all have value that you need to take into consideration. So I thought it would be helpful to also show some common mistakes that textile mills could make when electrifying. And I just got the alarm on my phone that I need to start wrapping up. So one common mistake is basically not sizing the system correctly. You need to know your actual load, your actual temperature and pressure requirement, and don't size the system based on the nameplate, because that will significantly reduce your capex and also significantly reduce your future opex. Also, the load demand, lower load, easier to connect to the grid. Do not need to electrify 100% from day one. If you do, great. But if you cannot, you don't need to. You can do the phase approach. Do not ignore the demand charges and other charges that your electricity bills have. You need to take everything into account when you do the economic analysis. And you certainly need to have renewable energy procurement strategy from day one. Even though you want to do it gradually, you need to have that strategy from day one. So let's move on for the interest of time. Financing, where the money comes from. You need to get the money from somewhere. We have listed 4 strategies here. There could be more. But the first one, of course, internal. You use your own money. That's straightforward if you have. If you don't, you can go to the brands. If you're working with the brands, supplying them. There are brands that are supporting decarbonization, even electrification. H&Ms and others, they are there. You can talk to them. There are various strategies they use. Apparel Impact Institute, AII, published a report last year, Brands Playbook for Financing Decarbonization. So has a number of strategies there. You can go to banks, especially banks that they have green loans. In India, for example, SIDBI and others, they do have loans for decarbonization technology, electrification included. And there are grants, like straight up free money. Apparel Impact Institute has actually grant directly for electrification projects. So if you're considering electrification, first thing you need to do is contact AII, because you might be able to get some money for your project. This is the snapshot of AII's brand playbook for financing decarbonization I mentioned. So there are different strategies. I highly encourage you to read them, even though it's written for brands, but you are the supplier. You can see which one could work with you and then discuss that with the brands you are supplying. Okay, to wrap up, once you have all that, you have the financing. Basically, you procure the technology, then you go for installation and commissioning. You need to sequence things. Electrical upgrade, transformer, etc., need to happen first, or at least in parallel, before you install your heat pump, for example. You can build your electrified technology system while having your production running smoothly, and then once the project is complete, then do the connection, preferably during the scheduled shutdown period. And then you have to, of course, test in the beginning, test performance, see if the COP, for example, the efficiency is as the vendor advertised, etc., and make sure everything runs smoothly. When the operation starts, or before the operation starts, you need to train your staff. Very important, how to work with the new equipment and the safety protocol. By the way, that's not a big deal. Industrial companies always do that, so it's not a deal breaker or anything. Install permanent metering system to measure efficiency and do optimization. And one advantage of electric technology is measuring, as you know, electricity is much easier than measuring, for example, steam, and it's much cheaper. So you can take advantage of that, do proper measuring, and based on that, do optimization. And I'm hoping with the AI and everything, you are going to see advanced optimization system come on top of these electrified technologies. And good data can help you with optimization and then help you with the expansion for the next phases. And last step is self-explanatory. Review what you have done, how things are performing, learn from what you have done, the mistakes, lessons learned. And then most companies we have at least worked with, they have the second line, they have the second plan, then scale from there. But having learned what you have learned, I think the second project will be a smooth. Or within the same plan, if you just electrify part of your load, like one boiler, you can gradually move to the next. Last slide is this one. Basically, your action plan for the next 24 months if you want to electrify. Most of the process will happen in year one, but especially implementation and commissioning, it will take some time. And that's why we thought it's realistically to assume that it will be a 2-year project. But most of the thing that you need to do to get to the final investment decision, all the steps that I walk you through, I've outlined here, would happen in year one. And if all goes well, especially if you could, get the financing, then yeah, the construction can happen even at the end, towards the end of year one, and you have in year two system operating. With that, I went a bit over time. Sorry, Puneet, but thank you. We do have that report mostly focusing on why and what of the electrification. And actually, we do have a chapter on how. But I hope you found this presentation kind of helpful in terms of walking you through these steps. With that, I stop here and I take questions at the end of our workshop, but I hand it over to Puneet to now tell you the steps for corporate RE procurement, which you tie to electrification in order basically to get to net zero or towards net zero. Puneet?
Thanks, Ali. Is the page showing the presentation or presenter's screen? Can you
It is
confirm?
showing, but it is not a full screen. Can you make it full screen, please?
Just a moment. Just a moment.
Okay. In the meantime, please type your questions in Q&A box. I see somebody raise hand. We won't be able to allow people to speak. It's more Q&A text box, and then we will read and answer them at the end. Puneet, can you share your screen?
Which screen is visible?
It's not showing your screen. Can you share again?
Just a moment.
Still just showing our videos. So. Okay, now we see your full screen, but it's not on slide one. Can you go to the first slide?
Yeah, just doing that. Just give me some.
Okay.
Okay, sorry for the glitch. Yeah, so let me take it forward to from where Ali left and come specifically to the corporate or renewable energy procurement, specifically for the textile companies in India, and considering specific examples from the states of Maharashtra, Gujarat, and Tamil Nadu, where Ali has done significant work, and we have also interacted with a lot of cluster players there. So the quickly covering the agenda. So we will just be spending some 5 minutes on the agenda context setting, and we will deep diving on what are the some of the key steps or key considerations and risks the the textile players should take into account while devising the renewable energy strategy and selecting the option, and a little bit time on what the synergy alliance where we and CII are working together along with other partners. Just starting initially with a poll. Ali, can you initiate this poll?
Sure. Give me a second.
Thank you. So
So,
what is the this poll will be about what is your current organization, current RE status, and what options you can select the options which are available. Is the poll closed?
yeah, it's going. Let's give it another 20 seconds. I see 47, 48 of 100 people. Last time 80 people responded. Hopefully we get 80 people. Okay, we got about 60, so let me and then share result. Can you see the results?
Yes, Ali, I can see the results. Okay.
Interesting.
Yes.
Okay. Looks like good amount
Should
of
I proceed?
countries, rooftop, and yeah. Should I
Sure.
stop sharing? Okay, go ahead.
Okay, so a little bit on, I think this particular thing was covered by Ali earlier also, and where we can see that the textile cluster is a heavy industrial consuming sector, where around 4% of total electricity consumption right now in the country is from the textile sector, and also 5 to 6% emissions also being coming from the textile sector. So that actually is a very big imperative, especially in the industrial sector, for the textile sector to decarbonize when we are targeting net zero target in the coming next 20, 30, 40 years. And specifically with respect to processes, we are all aware that the initial processes of spinning, weaving, knitting, these are some very energy intensive processes, whereas wet processing has an hybrid fuel usage in terms of fossil fuel burning as well as electricity in some clusters, and that's what Ali emphasized in converting that particular burning into the electrification of heat. So and is one thing specifically to note about textile sector, that it has a mix of all the kind of enterprises, from integrated mills to the MSME supply chain, small players as well as large players, which have different consumption loads across the supplier value chain of the textile sector. I will quickly just cover up this particular, like you can see that how the growth has picked up in the corporate procurement overall, not only in textile but overall with this C&I sector, and major growth has been observed in states of Karnataka, Tamil Nadu, Gujarat, Maharashtra, and Rajasthan, especially which are RE rich and have some favorable policy environment across RE. The key growth drivers specifically for C&I segment is definitely the high ever increasing cost of retail tariff of utilities, whereas where the C&I or commercial industry sectors suffers from the heavy burden of the cross subsidization from other categories of electricity consumers. Power deficit is a critical risk with the emerging demand from the sectors of industrial heat, data centers. The scenario is building that if sufficient power is not there, the cuts can be made to the industries. And over time, we have seen that RE market has developed a lot with lot of emerging options also there, as well as lowering cost of the existing and orthodox options in the RE. On regulatory compliance is also coming up and developing, and more enforcement is being now applicable to the C&I sector with RPO obligations in place, and the emerging compliances with respect to carbon border adjustment mechanism for European countries impacting the export oriented units, as well as the emerging disclosures of the listed companies which are required by SEBI under BRSR. Apart from that, the voluntary commitments which have been made by the companies across the globe and on the various platforms, and the initiatives also are making the drive towards the renewable energy for C&I and textile sector critically important. So coming specifically on understanding what are the key categories or what are the different sub steps which are required for RE procurement or textile sector, and just to be very clear, so there is no very panacea kind of process to do this. There would be some steps which you will do at the initial. You may skip one step, do the next step, and maybe come back. You have to revisit your earlier steps. So it's the initial three steps would be kind of mix of where you have to check back on what have you done on the earlier stuff. So there is no fixed strategy, but overall the approach towards how to decide the particular RE procurement mechanism or a particular RE procurement player or supplier specific to the energy needs, specific to the load profile of your organization and the plants, individually located or multiple located, that will actually be a factor in determining the correct RE procurement approach. So first, we what we understand is the understands your plant's energy reality. You have to be very clear about what is the current energy consumption profile of the plants or the plants in which you are operating. Is to the first step is to map both electricity and thermal energy use, because textiles are not purely electrical industry. Processes like spinning, weaving, knitting, garmenting are pretty electricity dominated, while wet processing has kind of a hybrid fuel usage from coal, lignite, biomass along with electricity. So Ali's report also showcases that textile finishing alone accounts for around 40 to 45% of total sector energy use, with still the coal is a dominant consumption. So practically, at least 12 months of electricity data, and if it is more, the better you can plan for the scenarios and attach the sensitivities with respect to various costs. As we can clearly understand from our last poll that the electricity economics as well as the financing are the biggest considerations, which means the current participants have voted for, and to determine that you need to have that particular data in place. So further, what important thing to consider here is to not to only focus on the overall bills as well as the average billing rates, and ignoring the other these load profiles of a plant during the day, as well as the seasonal variations which can be matched with the solar seasonalities. What is the continuous versus batch processes? What are the frequency of outages? And if there are any particular times of day where the consumption is high, so which can be related to the TOD tariffs or RE based concessional tariffs which are issued by utilities. So these all considerations are very important with respect to understanding your particular plant requirement. And now, given that advent of now smart meters are being deployed across all the countries, that kind of data bank you will already have, or you maybe the new players will be, once the smart meter are installed, they will get the visibility of that continuous 15-minute or 5-minute block wise data. So you have to first define your goals. Once you understand what is your energy consumption profile, is the next category is about clarity of intent, understanding why the company is pursuing renewable electricity. Is it like just a pure economics versus reliability? And today the discussion is not only on the economics of the particular option, but also the reliability. You cannot make your plant or machines suffer because of outages from discom or energy deficit kind of scenario. So that is important. What is a buyer client sustainability requirement? Is it, if you are an export oriented unit, are there implications of EU for which you are moving towards renewable energy? Or is it like more investor obligations coming, because more and more investors are now making their green commitments and investing in those companies which are actually green compliant? Further regulatory compliances, as already told, that RPO obligations have been enforced in Environmental Act, which are targeting around 43% to the obligated entity by 2030? What are the current pollution guidelines? And make and one more thing specific to highlight is even the consumers are now getting very much aware about whether they are procuring a product which is produced from green energy, and that actually makes the scope to scope 3 obligations to the big apparel and garment manufacturers, which have bearing on the textile companies. What are the reliability and energy security concerns, as I explained? And definitely there is a greater social obligations for the entities, and we have actually observed several of the companies who, apart from economics, apart from other considerations, are considering their larger social obligation towards adoption of RE and to remove the emissions from their plants and units. One specific considerations regarding this could be what is the kind of non-negotiability we want to have with respect to our goals. Are our goals short term? Is it something immediately short term pressure, or where are we planning for a going for a long term strategy for our of our total energy consumption? And also we have to evaluate the constraints related to whether we have a rooftop availability, specifically the condition of that particular rooftop for solar installation, what kind of ownership issues we have with respect to our or group company. Land is definitely rare, so open spaces in premises, are they present for maybe electrical infrastructure installation, grid transformer connection line? So these considerations have to be kept in mind while devising the goals going ahead for the RE. So these are some of the options which are very prominent and right now being talked about in the C&I clusters. And you have to first screen and identify what are the options available in the market. Some of the prominent options are captive, group captive through green energy, open access. The rules have been and the respective acts, regulations have been enforced in the states, and which are prominently taken up by large and continuous loads and the cluster level demand for the textile players. Rooftop solar, which are available with net metering, gross metering, and virtual net metering, also has been introduced in several states, which are preferably taken up by smaller and those who have daytime loads. And third party RESCO mode for rooftop solar, OPEX, and PPA mode for this captive and group captive through IPPs are also a preferred option for large integrated textile units, as well as those who have continuous loads and combined cluster demand. So this cluster demand I'm talking about because the green energy open access right now has talked about demand aggregation in several of the states, whereby a particular consumer having multiple connections can get a combined green and can get a combined capacity green energy open access from a utility based on several conditions. The other options which are picking up are the purchase from exchanges, which is mostly followed for urgent procurement to meet the RPO obligations, purchase of RECs for meeting the RPO deficit. But the markets have not got that much of turnover and volumes to affect the exact prices which are desired by the but the current prices are motivating people to opt for these options. One another option, green tariffs have been introduced by the utilities, and more states have issued it. But the only constraint with current green tariff mechanism provided right now with the states is regarding that they are charging premium over the existing industrial tariff. So unless and until when you actually come up with your landed cost of energy, you have to be considerate whether that premium is something which actually results into a overall profitability, or landed cost of energy is something that delta between the existing industrial tariff as well as the green tariff is something which is to be taken into consideration, especially, and these are something which are being enforced mostly by the export oriented units which are moving towards the CBAM requirement. This is the RE procurement model matrix, and this is something which was presented earlier also when in August we did a similar kind of webinar, and these are some of the options which you can exercise based on on-site captive rooftop solar. What kind of ownership of RE plant is required, and what are the key regulations you have to consider while actually selecting that procurement model. And you have to basically answer two important questions. Can this particular option supply the what kind of power I needed, and what is the tenure, what is the timing of that particular power, what is the reliability, and whether my plant can absorb that particular that particular power efficiently and effectively. So that is these are the two considerations you have to keep in mind. One thing which you have to consider is there has to be a provision of backup supply, and I understand there was a question asked in the chat also, that what are the backup supply options. So you anyways you have to have the utility backup supply option, which is the more prominent, apart from arranging for other energy storage can also be one of the backup supply. But it is always advisable, and which is most preferred option, is to have utility as a backup supply, and there are separate backup supply rates provided by utility which are concessional to the overall utility supply industrial tariffs. As you can see, these are some of the figures which actually demonstrate how the particular options are preferred in the sector. Open access is the most preferred option, followed by rooftop solars and RECs and the exchange-based RE power procurement. You can see that in the graph which is on right-hand side below, that what are the top five states in terms of RE procurement in megawatt. And the Green Energy Open Access portal has showcased that Tamil Nadu is now right now around 800 transactions have been effective, with Maharashtra only 127 and 285. So that particular regulatory and policy issues actually affect how the this green energy open access is being adopted by the various players. And you can see specifically with Karnataka, there was a very specific change which was effected in FY17, and which kind of incentivized the overall open access regime, and that kind of actually was a very promising step. And then that particular thing was actually removed, so that actually led to the fall of this particular open access mechanism in the future. So that this shows how the regulatory and the practical aspects of getting the approvals affect the particular adoption of renewable energy over the past few years. These are some key modes of RE procurement. I will not go that much into detail, because as I see that most of the people have actually moved ahead with the RE procurement, and these are some of the very prominent options: rooftop solar, which can be adopted through OPEX and CAPEX also, and it is a pretty less complex system with sufficient. Any consumer with having sufficient rooftop space can actually adopt this option. Landed tariff is less as compared to grid tariff in most of the landed cost of energy calculations. And net metering is a very promising option, but states generally shy of from giving net metering to the consumers. Open access for large consumers, integrated mills, this is the most preferred option. You need to have a very dedicated power management cell to manage this kind of open access mechanism, where a lot of intricacies are involved. You have to be regularly updated about the regulations, changing requirements. Like for example, in particular year banking will be allowed, in particular year banking will not be allowed. So those kind of considerations actually make it a little bit complex, but definitely the advantages in terms of lower RE cost at bus bar, coupled with cross subsidy and other charges for open access, still make it a promising option for a large scale textile players. These are some new mechanisms. So due to time shortage, I will not go into the detail on green power exchange, RECs, and green tariffs. And there is an emerging concept, and guidelines have been issued on virtual power purchase agreements also, which are now being evaluated by a lot of big players, and that we may cover later in some other convening. So this is a very important aspect when we, and as I've like, the landscape for particular regulatory and commercial feasibility changes fast with introduction of new regulation, introduction of amendment. So particularly every state has a state and electricity regulator which kind of issues these regulations. And when you go for a RE procurement, it's not a one-time exercise. You have to be watchful of what kind of regulatory developments are happening and what have happened in the past. So if you could say, the utility tariffs have been on an increasing trend since last many years, and they are going to increase further and further, with the given advantage of lower RE cost, and the other charges which have been applied to the textile players. This actually is still making promising to adopt RE. So one thing is, you have to check the whichever state you are operating in. Maybe if you're a developer, or the for the player from which you are procuring, which state he is operating, what is the RE procurement landscape, and what are the enforcements under the Electricity Act, and what are the national rules from which these particular regulations of state are guided. what is permitted, bankable, and financially viable option is another big consideration to be kept in mind. When evaluating the cost of or landed cost of energy for a particular option, one thing which is actually sometimes people ignore is the backup supply cost that has to be considered, and this has to be very comprehensive, as there are a lot of intricacies and what of charges which are being included in the open access regulations being introduced by state, as well as their tariff orders, like grid charges, metering and settlement requirements, grid connectivity. When you are going into captive or group captive or IPP based procurement, you have to be aware about what are the deviation charges. Any deviation in schedules can land you into big penalties. But these are now mostly system driven in most of the companies, as well as the utility side, it is system driven. So the chances of deviations are pretty less, but that has to be taken into account with some kind of sensitivity analysis built into your existing analysis which you do for landed cost of energy. TOD tariffs are being introduced, so you, if there is a quick option, you have to move to a TOD tariff, you can switch your particular production mechanism to that particular tariff. That would also give us advantage in terms of that. One important thing to highlight is, despite the regulatory and the commercial feasibility, what are the practical considerations of the utility, which is something which is kind of not written in regulations, and on the commercial side you will not witness. So what happens when you apply for a green energy open access? The application goes is applied to a central portal, and it goes to the state level SLDC as well as the transmission company for evaluation of that particular application. So every whatever states which we are interacting with utilities, I will not take the name, but internally they have devised some kind of bottlenecks or some kind of barriers in allowing some kind of particular structures. Like group captive is still not preferred because of the intricate complexities related to matching the and equity requirements to the energy requirements of those players who are in a group captive mechanism. So though it may be regulatory, on a regulatory front, it is allowed. On a commercial feasibility, it is coming as a good option. But when it comes to practical applicability in terms of whether utility will approve that mechanism under green energy open access, is an important consideration, because that will actually fail the complete option, and it will not go through. So what I say, if an option is not feasible regulatory or commercially and not practically, it will not work, no matter means how it will be looking good in terms of the delta which you are getting from landed cost of energy from your current utility tariffs. And one more thing is that the interstate open access is pretty much complicated. And when we talk of states like Maharashtra, Rajasthan, and Tamil Nadu, they itself have a lot of RE capacities present in the state. So that actually kinds of not actually is a deterrent, but it adds steps of complexities when the developer as well as or supplier is located in a different state from what your plant is located. Ali, can you help me on the second poll? As
Sure.
Yeah.
What helps the organization? Okay. Let me go back.
I
Okay.
request the audience to provide the answers on the poll.
So the question is, what is the biggest hurdle to procure offsite renewable electricity? What you have faced the most? And state regulation and surcharges, contract complexity, financing or credit constraints, developer reliability. Looks like the state regulation and surcharges coming up first. I guess these are exactly some of the things Puneet presenting. And perhaps, yeah, Puneet, you can point out more how they can deal with this.
Yeah, I will cover Ali once they reply. So maybe cover specifically to those who are actually facing a lot of in a particular domain, which domain they are facing a lot of hurdles. Yeah, is it
I'm,
close?
I'm sharing result now.
Okay.
So yeah, state regulations and surcharges looks like comes up first, and then financing or credit constraints.
Yeah. Okay. So that actually that's what I just covered in my earlier slide, that
Right.
you have to be watchful of the state regulations and policies, and there are some hurdles related to that. Let me just complete it, and maybe then we can deliberate more on based on the time availability. Should I
Yeah, if you
proceed?
could wrap up in about 5 or so minutes, that would be great. That would give us 15
Sure.
minutes for Q&A. Thank you. Go ahead.
So, coming now to what, since we have actually evaluated the whole landscape of what is our energy capacities, what are the available RE options, what are the regulatory and the commercial viability option. Now we have to come into whether to move towards the decision state and design a particular option along with the developer and what lock in the pathway towards RE capacity. So. The first decision is mostly about the ownership and the risk appetite. Some companies preferred asset-light models, third-party PPAs, or green tariffs to minimize the balance sheet exposure. Others are more comfortable owning the assets through captive or group captive structures to maximize their long-term savings based on the capital they means based on the capital resources they have. There is no universally superior model right now, but the right choice depends on what is the financial strategy you are having, what is the governance capacity, and that this becomes very important when you get into such kind of structure. You need to have dedicated staff taking care of these electricity regulations, monitoring of PPAs, and as well as monitoring of the consumption and what are the options, especially when as was the question earlier asked that what is the can we do hybrid kind of models. So that hybrid models itself will include that kind of dedication from the particular department. And what is the risk tolerance? So when we say low risk appetite, third party PPA, green tariffs, OPEX rooftop, which are mostly for garment finishing, smaller MSME units, they have a lower risk appetite. And when we have big integrated textile units, spinning and weaving looms, higher risk appetite is there, and they can go for captive and group captive and capex based rooftop considerations. Uh, just important consideration is that do not as I said that it's not like only the lowest tariff will actually give a best way. You have to have consider the other risks and associated with that, and you should be carefully estimating your risk and maybe develop that kind of sensitivity scenario models into look into if there is a particular regulation which is removed, and if it is making favorable, how the range of that landed cost of energy becomes. So, and that is what is to be considered first. This is an indicative decision tree. There is no specificity, but that's what how we have evaluated this particular problem or challenge for the textile sector is what based on what is your electricity demand profile. Maybe smaller loads can go for rooftop space, and large and continuous loads can opt for offsite RE feasible in state because land is a precious thing. So those commercial players who have actually established solar parks and those who have larger RE capacities installed, they can be a easy supplier pool where you can get through offsite RE feasible. And so, and when you don't have want to get into that kind of management of electricity with respect, you can opt for green tariff or RECs, which are a bit premium over the industrial tariffs, but that can actually be helpful in making you go away with the other managing the department as well as dedicated staff and monitoring mechanisms to be in place for other captive and group captive and IPP based models. So, what the final check which you could opt for before locking is that what is this the particular model is ready to deliver the power when I need it, and and whether it is reliable, is it regulatory feasible, and can we start small and can scale up maybe like starting at 20%, 40%, and then going ahead with the full decarbonization. So you are making a definitely a long-term choice. You have to carefully and wisely decide about the capacity sizing. What we have noticed based on our surveys in several clusters is that to start with 40 to 70% of demand, particularly for open access contract, over contracting leads to underutilization and actually kind of erode your financial savings if not planned or structured properly. One important thing with respect to when you are evaluating a PPA kind of structure, so change in law clauses, curtailment provisions, what are the scheduling responsibilities, how the risks and penalties are being shared between the developer or supplier and the procurer. So that particular clauses have to be carefully means evaluated as well as negotiated. Tenure flexibility requirement, what are the performance guarantees, whether it is a right of refusal and what is the cost of right of refusal, what are the obligations related to CEF are some of the important things you have to consider while devising a particular PPA structure or entering into a contractual structure with a supplier. Internal alignment is definitely essential, and as I've been means emphasizing that you have plant teams, finance, and senior management must be understanding these risks and assumptions. And conservative modeling and phased approaches significantly improves the approval process. And this is the category where most value is either created or lost. So you have to spend a time in properly devising this particular RE strategy. One important thing is that so when you have to be aware about whether this is right now a supplier ecosystem or a buyer ecosystem, so that helps you in negotiating the rates. And even if there is a large scale procurement, you can initiate a tendering process or reverse bidding where many suppliers can bid and give you a best possible tariff on a particular approach you have selected. So one important consideration is you have to be watchful of the regulatory and the policy changes, and that is one of the biggest risks going ahead in the electricity procurement. So last is basically how to implement, and one important consideration while implementation is the gestation period of particular option. What are the attention to approvals? How the engagement with utilities and regulators is there? That actually when I talked about the practical implication, though some things are regulatory allowed, legally allowed, but practical considerations are more important in evaluating certain options. You have to regularly monitor performance, cost, and compliance related obligations, specifically when you have a captive green energy or IPP based green energy open access. And further, it's like you have already done a lot of work when you move ahead with the RE procurement. So you with the growing options and growing landscape of RE procurement, you have to optimize and expand to diversify your RE portfolio over times. And there are more and more hybrids options are available, and now even the storage costs are going down, and people are evaluating the C&I sector distribution level storage options to have that RTC kind of a supply or backup supply in the particular things. So these are some of the steps. Due to time shortage, I will be closing this, and maybe we can get into the questions. Ali, do you want
Yeah.
to add something? Just 1 minute I will take, Ali, before closing. Is to we have along with CII, WRI India has launched a Synergy Alliance on September 2025, and this is a C&I sector focused alliance which actually creates a broader buyer platform to leverage the aggregated demand to seek policy and regulatory changes, establish demand for green electricity from clusters of industries to electrify low to medium heat temperatures, and explore various applications, models, and technologies to improve to bridge the demand supply gap of RE adoption at scale. This is just a snapshot of what kind of sub activities and subgroups we are planning going ahead with this Energy Alliance. And we are thankful for Global Efficiency Intel and Ali for giving us a podium to present these some of the pathways which are important for the textile sector. Yes, Ali.
Yeah. Thank you so much, Puneet. Yeah, I see. As you all saw, there is a lot of content. As I said, our first challenge was the time, how to compress everything into such a short period of time. Puneet, perhaps we can stop sharing your screen. We still see your screen. Yeah, perfect. So I see that the questions are coming in. Thank you for typing your questions in the chat box. So just to give Puneet also to read through some of the questions, I wanted to ask the participant a quick question for future webinar because, as I said, 300 people registered, 100 plus people showed up. So we see a lot of interest in this, and we would like to perhaps have some future workshops. So I have a question here. I hope you can see. it's not multiple choice. It's just you type it in a few words. Which topics or steps of the process, either electrification process or renewable energy procurement, you would like us to cover in more detail and more deep dive in future webinars and training workshops. So hopefully we get good number of you reply to this question, and then we can map things over and see if there are themes perhaps we can include in the future training workshop. So I give it a minute. Please do participate. That's helpful for us to see what is the demand out there from you guys so we can uh, organize this. We do have a lot of information. When you go to WRI India website, you will see they have a ton of reports on this topic. If you go to our website, we have a ton of report on electrification and textile industry. It's just picking the right topics and within the short period of time presenting it. That's what we are hoping we can get from you. Okay, let's give it a minute, and Puneet, perhaps you can look through some of the questions came, and then I can perhaps read. So I can keep the poll open, and while um, start answering some of these questions. So, first question is levelized cost of energy or heating for biomass. So, I didn't present it because I believe for the India report, we did not include biomass, but in the other roadmap report that I mentioned, we published a year ago with Apparel Impact Institute, we did include biomass and natural gas in addition to electrification and coal. So if you go to that report, which I shared with you the link earlier, low carbon thermal energy roadmap for textile industry, you will find biomass data. There is a question, Puneet, on someone is saying they did a PPA in Tamil Nadu and initially they were set up as a owner, but then some regulation changed and then they are not having the ownership of the green credential. The question is there any way around this ruling in Tamil Nadu, and is this common issue that is being experienced by textile mills in Tamil Nadu or others? Puneet, do you know about this issue, the regulation change in Tamil Nadu?
I can get back to the participant on this specific question. I'm not because I'm not interacted on this particular issue, and that was not highlight when we did that. This particular thing was not highlighted in our two workshops, but definitely I can get back to you to that particular participant about this thing.
Okay.
Is it something which is only specific to their company, or is it something which is the experience by a large number of players due to some particular regulation change?
Sounds good. So moving on to next question, it was asked, could you suggest a suitable heat pump model capable of providing heat up to 100 degrees Celsius? Actually, heat up to 100 degrees Celsius is the easy one. You can fairly easily purchase industrial heat pump today that give you heat up to 100 degrees Celsius. If you want hot water heat, especially that many companies are using it, may not be textile, but food and others. So that's way more commercial. It's the steam that is commercial, but less adopted. But it's still like 100 degrees is we consider on the lower temperature side is much easier. A lot of the things we are talking today is like, going to 150 degrees C. Although, as you know, many steam demand in textile is actually you need 120 degrees C or below. So the answer is yes, you can find that in the market. I'm not going to suggest any particular vendors, but you can go our textile heating electrification tool, see the list of the vendors, and yeah, see on their website they're offering. But that's on the easy side of heat pump electrification. Um, Winnie, do you see a question on RE you want to address?
No, they are mostly on the heat pumps. I think they're much more aware about the
Yeah.
RE thing. But let me just that REC thing. I will get back to that particular participant.
Okay.
Uh, yeah.
So then I'll go ahead. One question is, what's the typical efficiency of electric boilers versus coal versus biomass. As I mentioned during the webinar, electric boilers typically have like 99% efficiency. 98, 99 is often cited. Heat pumps is the COP, and for a steam generating heat pump, often reported between COP of 2 to 3, which means basically 200 to 300% efficiency. For coal and biomass, it depends on the age. As you know, coal boilers, the new ones could be even 80%, typically between 70 to 80%. We have seen really old ones that they haven't done any retrofit even below 70% efficiency. Biomass also varies, uh, significantly impacted by the moisture in the biomass, as you know. So there's a range there as well. But typically for conventional boilers, you get between 70 to 80% on the average. One question is, what is the general payback period on industrial steam generating heat pump for large scale dyeing facility in India? That's a very good question. So this is actually a question that comes up, and unfortunately, the common practice in industry is just looking at payback, and anything above 3 years or 2 years even they disqualify. But as I said, we advocate for a better indicator, which is basically life cycle cost, levelized cost, because that takes into account over a lifetime of technology how much money you can save. But if you do run the payback period, which by the way, our textile heating electrification tool gives you the payback period, it depends on the cost of your fuel you're buying now, cost of your electricity you can lock in. Some of the RE procurement in India, they're significantly lower cost than grid, as you know, in certain regions. So it can vary. But what we have seen typically is more than 5 years. It could be up to even 10 years in some cases, depends. I'm not saying for India, overall, the studies we have done. But then there are grants. As I said, AII today, you can go, they have electrification grants. If you get, let's say 20%, 10%, 20% of the CapEx from grants, whether through the brands or AII or others, and then the payback period can be shorter. So there is not one definitive answer.
Yeah, can I take one question, Ali?
Yes,
I think
please.
there is one question on what are the various options in terms of what are the technologies available in terms of energy storage. And specifically, I can answer this for India is that the most commercially viable energy storage technology is lithium ion based, and pumped hydro is there, but that is actually at the utility scale. One thing, there are other thermal energy storage technologies also available in terms of hot water tanks, pressurized systems, and that I think that has been covered by in the previous section. But specifically, when this is something which we are evaluating is to whether the applications of storage, particular to C&I sector establishment, is this something which is viable or not? Are the financing available for that particular option? And also the regulatory provisions regarding such installation at C&I sector level. So distribution level and transmission level, government has come up with a clear guideline, but at the CNI level, that is something which is to be explored further, and that we are doing. One specific question on scope 2 for reporting renewable, is there any renewable energy on-site, off-site emission factor which will be considered as zero, having some emission factor for renewable energy scope? So the answer is yes. For scope 2 reporting, renewable electricity is generally treated as having zero emissions, but only there are several conditions attached to it which needs to be considered. Zero emission factor is actually based only for market-based scope 2 and with proper contractual instrument. So it is not automatically for all kinds of renewable electricity. Yes, Ali.
Yep. Thank you, Puneet. So there are questions about the vendors for electrification technologies. Again, there is a vendors database in our tool. You can go download the tool for free and see the vendors database. But that's not even exhaustive, especially heat pump. We are seeing more and more heat pump manufacturers and suppliers. In India, there are a couple at least. I don't want to name to advocate, but there are a couple of strong candidates, especially one of them. As we speak, they are negotiating for a project in textile company. in India. By the way, in Vietnam, with the support from H&M and AII, there is a textile plant installing a steam generating heat pump. In China, there is another one. They have already installed it. In India, I believe there was one, if I'm not mistaken, the Epic Group that did, but for lower temperature. And there is more to happen. I am myself a part of a review committee of some grants. So you will hear more and more about in the near future, in the next couple of years, more textile companies in India, China, Vietnam, and others installing a steam generating heat pump. So this is not hypothetical. This is real world happening. There was a question on, okay, I see we went over time. We can take a couple of questions and just end it. So there is a question that basically saying the heat pump doing the first step heating to pre-water the makeup, to preheat the makeup water for boiler, and then the boiler basically heat to steam. Yeah, this is a very simple configuration that people propose, and it's okay. It will save some energy and fuel and emissions, but it will still leave you the significant chunk of fuel use and emissions. Keep in mind, only 10% of when you generate a steam, only 10% of the fuel is used to lift the water temperature from, let's say, 20 degrees Celsius to a water of 100 degrees Celsius. About 90% of fuel that is used in the boiler is to take the water from 90 degrees Celsius, from water from 100 degrees Celsius to a steam of, let's say, 120, 30 degrees Celsius. So because of the enthalpy of evaporation. So if you use heat pump to like do the, heating for the makeup water, yeah, you save some fuel, but you're missing that big chunk for the steam generation that's going to remain fuel. So that's why we do not advocate for that. You better to go for a steam generating heat pump if you really want to slash your emissions. Okay, I see people have dropped and we went over time. It's been 1.5 hours. I think we addressed most of the questions. Sorry if a few questions remain, but don't want to make people stay for too long. But thank you very much for attending the workshop. I hope you find it helpful. We tried to focus on how, but you saw we had limited time. Hopefully, we will have opportunities to have more workshop and have more deeper dive that is more useful for textile companies in India and other countries. Puneet, do you have any final words?
Yes, I'm very grateful to you for giving the opportunity to present this to global audience, and many thanks to the participants. Feedback is welcome from all. You can mail it to Ali, he can forward it to me, and you can also provide the feedback. So we may be able to refine based on your actual practical inputs going ahead, and maybe come up with a more updated and refined content to you. Thank you. Thank you.
Great. Thank you very much. Thank you, everyone. Have a nice day. Bye, everyone.